Yeah, yesterday class we have discussed about association of elements. In that part, we have seen the indicator and the pathfinder elements. And today we are going to discussing about the patterns of a geochemical distribution. Yeah, in a geochemical distribution, whatever area you have chosen, that must and should we have to see the based on the geographical distribution of a given elements. And those elements we are searching in different rocks and soils and other materials also. So, there are two types of environment we have seen. One, it is that deep-seated environment, and second one, it is a superficial environment. In hydrothermal alteration, this deep-seated environment will be formed, whereas due to the weathering, erosion, and variety of other processes, the superficial environment we can find out. So, the recognition patterns, how we can recognize the patterns, it's related to the ore deposits. And main aim it is to function of a geochemical exploration. Its effects are related to the ore are intense, and it's related to the local and distinction from the normal process. So first we have to select the area. Whether that area is related to the primary environment or the sample we are going to collecting from the secondary environment. So secondary environment here, it's speaking about superficial environment. Yeah, as per that, we'll do the sampling. Once the sample finished, that's maybe the sampling media, maybe it is a rock, or maybe it is a soil, or maybe it is a water, or it's a stream sediment sample, or whatever it is there. And first, we have to collect the sample from the different locations in chosen area. So before going to that, we have to know the background values of different elements. These normal background values are useful for to find out the where the threshold values and where the anomaly zones we will find out as per this. In a normal abundance value, of any element in unmineralized earth material, it's a commonly we are calling that as a background. Suppose example for if you say the uranium actually in a soils will get 1 ppm in an average composition. Suppose you have a samples, you have collected samples from the different locations that belong to the soils. Then once you have done the analysis and you get the data from laboratories and you check out that the results of different samples, the sample results, maybe it is, you can see the different, it's a maximum of 1 ppm above. The maximum of 1 ppm above, and again you see the average value of all the samples. The average value of all the samples, again, if we get the same above the 1 ppm of value, suppose maybe around you get a 10 ppm or 15 ppm up to 20 or 50, 55 ppm in soils. So that just you can check. The normally the uranium it is presented in soils, actually it is 1 ppm. If it is exceeded that, if we get above that 1 ppm value, that is called as a above the background value. Above the background value. So these above the background values of samples, we do the again. We do the again the average, then we'll get the threshold values. So that here the distribution of any element in a particular earth material, that's it's found very rarely uniform. Thus, it is usually more realistic to view background as a range rather than as an absolute value. Even in a relatively uniform environment, the nature of the environment itself, it can also have a marked influence on a distribution. Definitely, we can say yes. Definitely, it is showing the influence on a environment. Either maybe it is belongs to the primary environment or secondary environment. Yeah, whatever type of a sample it is involved, the range of background values should be determined or recognized whenever the new area is studied. So now we can fix the geochemical. What is geochemical anomaly? What is a geochemical anomaly? An anomaly is a deviation from the norm. A geochemical anomaly, it's a more especially, it is a departure from the geochemical patterns that are normal or a given area or in a geochemical environment. Suppose if you see the deposit, the deposit, maybe it's a related to the abnormal phenomenon, or maybe it's having the geochemical anomaly, but how we can recognizable the patterns. Then again, we have to say the geochemical dispersions. The geochemical dispersions means from the deposit area, how they are showing the trending and how it is showing the trending from the location to the other areas. So as per that, we can say the dispersion is related to either it's the genesis or to the erosion, to the ore deposit of anomaly. So the anomaly, it's playing a very important role in a significant anomaly. Anomalies that are related to the ore and it can be used as a guides to, it can be used as a guides to ore or termed as a significant anomalies. Such anomalies usually consist of values which are higher than background. So negative anomalies are rarely useful in searching for a ore. Negative anomaly is far away from the genesis of the ore deposit. And then it's also playing the very important role. The negative anomaly is also playing the very important role to searching of the ore deposits. The non-significant anomaly. When you come into the non-significant anomaly, the high content of the indicator element can rise from non-economic mineralization by a geological or geochemical processes, and it's unrelated to the ore deposit. Such superspecially similar anomalies unrelated to ore are termed as non-significant anomalies. Then what about the threshold value? If the threshold, it is the concentration of an indicator element, and it is about which means the sample where it is considered the anomalous. In the simple case, we see that the threshold, it is the upper limit of a normal background fluctuations. Suppose if you have collected the samples from different locations, and we will see the average values for all the areas, for all the locations, so that some values are having the below the background value and some values are having the above the background values. So we'll calculate the average value, minimum value and maximum value. Based on these fluctuations, the upper limit of a normal background value or the upper limit of a normal background value, it is called as a threshold. The higher values of above the threshold anomalies and the lower values we consider the background. In a more complex cases, the two or more types of the threshold values may be recognized. The recognition of a regional or local threshold can be extremely important, or it's playing a very important role in prospecting of a different ore deposits. And maybe sometimes we do the preliminary investigation in a regional sampling. And the preliminary investigation of in a regional sampling, we collect the samples from the different locations randomly, and it's a covered more area. As per that, we'll fix certain areas and we recognize certain areas as a mineral deposited or ore deposits. So first, when we'll conduct the recognition survey in that area and we'll collect the samples and we do the analysis, and after that we'll get the results, and as per the database and we'll fix the some threshold values, and as per the threshold values again we'll do the analysis, again we'll do the detailed survey. In a detailed survey, again, we will do the collective samples from different locations where above the normal background values were fixed. From that locations, we have to, and we need to collect the samples and we do the analysis. We do the analysis and we see the laboratory data. Okay. Then again, we need to compare the previous one. We need to compare the previous one. Previous one means previous in a recognized survey, what it is that sample areas are having the background values. How many samples they have exceeded? They were exceeded the normal background values. So those samples again we need to check out once, and we have to study the comparing. Then after comparison study, and then we come to the conclusion, yes, that area, it has an anomalous zone and it has a dispersed through that area, and dispersed trends also we have to show. Those are dispersed trends, that's maybe it's a, sometimes maybe it is a deviated from the whole genesis area. So as per this, we will fix that area it has an anomalous zone or not. And different sampling media, it will become in a long question as different sampling medias in geochemical exploration. Those sampling medias are we see the quantitatively if it determined of the anomalous distribution of certain elements in the surface soil and subsurface ore pattern, and comparison with the known for the geochemical prospecting. The common practice followed in the geochemical method, it's a collecting of the soils particularly. But not only collecting of the soils, we do the stream sediments, waters, rock samples at regular intervals. Yes, here the regular intervals means we need to prepare grid lines, or the sample it should be collected from the field as per the grid pattern. Suppose example for just we have to imagine we have selected the 100 square kilometer area for a sample. We don't know what it is the mineral deposit, if it is presented in that one, we don't know. But yes, something was there. So what we have to do? We have to select that area. Approximately, we have selected that area 100 square kilometers. But how we collect the sample from 100 square kilometers? We do the as per a scale. We do the grids, and we make a traverse lines. As per the traverse lines and as per the grid pattern, from the center of the grid, we have to collect the sample. So that, suppose that's maybe in 100 square kilometers of area, it has a valleys and it has a hills and it has a landforms, and all those geomorphological, geological features we have identified, and we have to note everything, and structural, including the structural features also we have to note, and then we collect the sample from the different locations and according to the grid pattern. And you make it traverse. You make a traverse, and as per the traverse line, we will collect the samples in mid of a grid. So there are various types of sampling medias or sampling medias we'll use in particular geochemical point of view. Yeah, geochemical methods are very effective in locating target areas in the base of a metal mineralization. Yeah, the first one is the soil sampling. We see in the soil sampling, particularly the residual soils are playing a very important role to collect samples. These residual soils in temperature and tropical regions are carrying the mineral particles from the parent rocks. So, soil geochemical and the soil sampling. The soil sampling, its main aim, it is to recognize in the values and highest anomalous points and highest threshold areas we'll able to identify. And second one, it is the stream sediment sampling. The stream sediment sampling is the most widely used technique in geochemical surveys, and the very fine stream sediments we collecting from the field. Those stream sediment samples from active stream channels or floodplains to carry the mineral matter very fine and delivered from their original source of a rock. Yeah, water samples also, we need to collect the water samples also. The water samples which are useful for detecting the uranium and other mineral deposits. And rock samples, the rock samples, whatever rock samples or outcrops, it is visible to oil, and we'll cutting that out tips and we'll collect the samples. And sometimes also we may chance to get to the volatile and the airborne particles also. Those it's atmospheric gases. These atmospheric gases which are emanating from ore deposits or oil fields have recently attracted the attention of the possible exploration guides. The characteristics of a smell of mine dump containing the sulfides, it's a very good example to find out the dump deposits, to find out the dump containing and it's have a sulfide material. And these gases it's containing the pore spaces of a rock and soils, it's represent the mixture of atmospheric gases and gases of a deep-seated origin, and the gases are shallow in origin also. So, yeah, when you come into the particularly when biogeochemical exploration or a geobotanical exploration, these biogeochemical or geobotanical exploration, we do the systematical sample trees and the shelves for a trace or ore metals. It was a first geochemical method was investigated in the early 1930s. VM Goldsmith was a pioneer in a geochemistry. He was made the observation that the humus of a forest soils and soils was very much enriched. It's a most of the minor elements. It has most of the minor and the trace elements. He deduced that some trace elements must be correspondingly enriched into the plants from which humus it was derived. So he was made that the first suggestion that analysis of the plant material also playing a very important role, and it might have been an effective method for a prospecting. In later years, this method it was exploration came down with the known biogeochemical method. Just in the morphological features of a plant observation, if you see the morphological features of the plants, when we used as a guide to buried ore, it's known as a geochemical prospecting, geobotanical prospecting, whereas biogeochemical method, it's required the chemical analysis of the plant organs. The geobotanical method depend on a direct observation of plant morphology and the distribution of a plant species. Therefore, geobotanical methods have very great advantage of geochemical methods of prospecting in that results of a survey immediately available without a further treatment of the sample. So what type of a sample it's required to us? Yes, definitely we say the plant roots, the plant bark, the plant leaves, and pollen grains also. We'll collect the pollen grains also. The growth and the distribution of a particular plant in a given an area, it's known as influenced by the surface geology. Must. Yes, definitely it is impacting by the surface geological material. The geobotanical surveys involves, it's a visually study of the nature and the distribution, the vegetative cover, and the plant, how they were distributed in that particular location, and some indicator plants, it is useful for to identification of a different uh, mineral deposits or ore deposits, and morphological changes in the species that's introduced by a mineral enrichment, and other features also we have to identify here. Yeah, as per that, we fix the biogeochemical anomalies. The biogeochemical anomalies are areas where the vegetation contains abnormally high concentration of metals. If metal content of a sample's plant material is to be useful in prospecting, and it should be where the very simple relationship to the metal content of the bedrock. Yeah, definitely. When you come into the plant studies, we know that the plants which are having the planted under the nearer to the subsurface, the roots were settled down under the surface, and it's absorbing all elements and all major elements or trace or rare earths or sometimes maybe it's a finer, and these are all will be absorbing through the root cappings, so that these metal contents which are involved and enter into the plant's body, and they will be transported by the water throughout the plant structure. So then we will collect the sample from the root, then we will collect the sample from the bark and plant leaves also. After collecting that the sample it should be dried, and then you cut down into small pieces and put into the muffle furnace, and they convert into the ash at a 450 degrees centigrade without any burning of elements. So then as per this, we can see and we can fix and we can find out the pH and EH temperature, and including the soil moisture, and these are all the influenced. These are all the influenced on the background values. Yeah, there are different species of a plant which take up different amounts of inorganic material from the soil. The part of the plant selected and for the analysis, and it's playing the very important role, and it's giving the clear information about that particular area and which minerals which are having or what type of elements they are present on the surface. Like as per this or based on this data, we have to identify that the concentration of trace elements is found to decrease into the order. That's maybe it's the leaves, twigs, cones, wood roots, and the bark material. The biogeochemical prospecting methods have advantage over the geochemical techniques. The potential of accumulation of elements from considerable depth below the surface. And easy access of a vegetation for sampling are the important advantage of this one. Yeah, next one it is the geochemical, geobotanical indicators. Yeah, geobotanical indicators. The geobotanical survey, which involves the visual study of the nature and distribution of the vegetation cover, the plant's distribution. The presence of the indicator plants, its habitational or morphological changes in different species in different areas, and which are introduced by the mineral enrichment. How we can track? The tracking of indicator plants is more useful in the exploration point of view. There are two types of indicator plants are recognized. One, it is a universal indicators, and second one, it is a local indicators. Your universal indicators grow only on mineralized terrain and are seen that world over it's a similar setup it has. And they are, of course, they are rare in their occurrences and distribution. Definitely, we can say that every element and every metal, it has a own mobility capability, and as per that, they will move and they will occur in a different rock formations. Suppose in universal indicators are recognized as for cobalt, copper, selenium, uranium, and vanadium, including with the zinc. The local indicators are the more common. It's a more than 60 species of local indicators have been recognized for following elements. Those are cobalt, copper, ferrous, plumbum, manganese, molybdenum, nickel, phosphorus, selenium, uranium, argentinum, vanadium, and zinc. Yeah, this division it was useful for particular practical uses. Yeah. The geobotanical indicators have been used in to locating and mapping the groundwater saline deposits and the hydrocarbons or rock types, and as well as different ore rock formation, ore deposits also. Yeah, next coming into the drilling methods, sampling methods, and the estimation of ore deposits. Yeah. Yeah. Next, coming to the drilling methods, sampling methods, and estimation of ore deposits. We see here. Yes. Yeah. Drilling, it is a drill, it's a make, it's a possible to investigate for blocks of a ground that by other means we would like. The accessible and much greater expense. So in some investigations, drill holes are intended merely secure the geological information and the position of a contact and the attitude of a formation. The sequence is stratigraphic columns. As per these, we may find out the depth of the ore deposit and what type of deposit was formed. Sometimes we may get the vein deposits. Sometimes may we get the cross section of our ore deposits. So for that purpose, must and should we have to drill that area. The drill holes also used to take the samples from the ore, and it's providing the information what we are required to estimation of tonnage and grade of ore deposit. Yeah, there are many mines to the resident geologist is incomplete the charge of drilling from the designing to the exploration activity to the logging, cutting, and code the samples. And also he will do the analysis and interpretation of the data also. The geologist usually has the responsibility for recommending the location of drill holes and of the recording the result of that work, particular work. The sampling process, it's taking a small portion which shall be the representative of the whole. The consistency is a general known as the assay value of the ore. So that master should we have to calculate that the assay value of a ore. Although useful reasons for sampling a mine are a mineral property, it's a primarily economic, and the resulting the assay returns the constitution data of a truly geological character. It's reflecting the geological characters and reflecting the geological formation in the subsurface area. So that the sampling such the more quantitative in their nature, that most of the available geological data. The sampling is carried out at any exposed surface of the ore body, such as outcrop, shaft, drifts, crosscuts, or rises in the ore. Test bits or drill holes may sunk for the purpose of obtaining the sample. And then we need some computer the reserve of ore material to extract the mineral deposits. Either maybe it is useful for economically or not. The ore reserve presents the quantity of ore available in the deposit in tonnages. So that we need to estimate the tonnage, and it is involving the two factors. One, it is the weight of the ore, and second one, it is the volume of a ore. Yeah, drilling. What is drilling? How we will do drilling? Where we will do drill? Yeah, drilling or it's a boring. It's a process to dividing the holes and to driving the holes into the rocks. For what? And then we collect the sample from the different rocks where we have drilled the holes on the rock surface, and it's a cut during the process of the drilling. Maybe it's used for the purpose of testing for a chemical analysis, and some of the core samples we collect from the holes, and it is useful for to study of a or microscopic. And simple wash of the bore, it can be used for drilling its shallow depths. In the case of a mineral exploration, it's a sophisticated equipment it's required to collect the samples from the deeper levels. Any drilling program you should take, the main aim it is to establish the strike-wise and dip-wise continuity or discontinuity formations. So that for this purpose, the interval of a drilling has to be chosen on the basis of availability of geological information. It should be kept in the view of establishing and the continuity of the ore at the depth of intersecting of ore body at a various feature mining levels. And also drilling, it should be aimed to establishing the various structural projections. And there are various drilling methods we have. That's we see that now. One, it is a percussive. Second one, it is a iterative. Third one is a rotative. Fourth one, it is a cutting. Fifth one is a rotative. And sixth one, it is a shearing and a rotative, finally crushing. When you come into the percussive drilling, the rock is broken by the repetitive impact. In this group, 5 types of drills it can recognize. There are pneumatic drills, down the hole drills, independent rotation drills, motor drills, and cable churn drills. In iterative drilling, the rock itself it is in the ground or by abrasive action. 2 types of drills are recognized in these groups. One it is a diamond drills, and second one it is a sharp calyx drill. In rotative cutting drill, the rock is cut out, planned away. All other drills fall within this group. In the rotative shearing method, the rock is fermented and it has a wedge action. And this group is including the drag bit holes as a rotary and percussive drills. In rotative crushing method, it's also rocks are broken by wedge action, but the wedge action is used in combination with the thrust. All heavy rotary drills fall within this group. Yes. And again, all of the drilling methods and types, we see that the diamond drilling it is the most versatile and maximum we will use in particular mineral exploration. Churn drilling and rotated drilling it's also find use in the mineral exploration, but anyway, which are used in a limited. Diamond drilling. In the diamond drills, which use for surface as well as a subsurface drilling, a cylindrical bit it has, and it's impregnated with a diamond. It's connected with a string, it has a shallow jointed tubes, and it is rotating by the mechanical device. And it's maybe diesel engine or a pneumatic compressor device we'll use. Water drilling much, and in some cases we use the circulated through the hollow tubes to keep the pitch cool and wash out the cuttings.